Hi everyone, welcome to this programming class where we are going to look at program execution and errors in Python. So this is a very interesting class where we're going to learn how Python executes the program, what is the Python virtual machine and stuff, what are the different types of errors and how you can debug the program. Debugging is something that every software engineer and a programmer does to find the errors in the program. Okay, so let's go ahead and get this class started. And before I begin, I just want to say, do check out the other courses on our website. We have physics, chemistry, maths. We also have now biology for CBSE class 9, 10. We'll also be starting biology for CBSE class 8. So that course should be launched by tomorrow. So do take a look at our other subjects if you haven't taken them. We also have ICSE courses, physics, chemistry, maths, ICSE courses. So guys, if you haven't taken the other subjects, do take them and do share it with your friends. We also have Java coding in addition to Python coding, and we have physics and chemistry for the Cambridge IGCSE board, that is the international board. All right guys, let's get started here. So first let's talk about compilation. So what is compilation? You have heard of this term before? In compilation, what are you doing? You're basically converting the program into machine code. Right, just like if you do in Java, C++, any language. So in Python, when we write a program, what is that source code called? What is the name of the file? Do you guys remember? What do we call it in Python? Okay, it's called a Python script or a Python program. Very good. And so you write something like, a program.py, the Python file that we write, right guys? Okay, and then it runs through a compiler. Okay. And when it runs through the compiler, right? So even though Python is an interpreted language, that's half true, it runs through a compiler and it gets converted into something which is special called bytecode. So rather than taking the Python example here, let's take the normal language like C++. Okay. So first let's start off with a C++ kind of example. What does it do? So when you write a C++ program, let's say, program.cpp C++ file, it runs through a compiler and it gets converted into machine code. What is machine code? It's a bunch of zeros and ones. Okay, because computer only understands binary stuff. Binary, machine code, very good. It means binary. So basically what is happening, it's like translation. Our computer program which we have typed in a language like C++ or whatever is getting converted into machine code. Who is doing this conversion, guys? Who's doing the conversion? Very good. It is the compiler. So can I say that the compiler is acting like a translator? Our compiler here basically acts like a translator. Do you guys agree? And yes, the compiler typically does, it doesn't do it line by line, it does it in one shot. Okay, so it takes the whole program and compiles it into machine code. So this is what we are familiar with, but Python is something different. Okay, it's something like Java, and I'm going to discuss about that. So this is what happens in normal compilation. When you take some source code, okay, one shot means the entire code is taken and translated. It's not done line by line. It takes the entire program that you have written and it compiles it into, binary code. It's like if I tell you, let's say I don't know German and you have got a great German book for me, right? So then what will I tell you? Can you please translate the whole book and give it to me? So similarly, Python translates the whole code that you have written, not Python, the compiler translates the whole code that you have written into machine code. Okay. So this is the normal situation, normal compilation, for example, for languages like C++. Okay. So what happens is that you can see that when it compiles, will the machine code output be same for a Windows machine, a Mac machine or a Linux machine? Do you guys think the translation is going to be same? No, because please understand that it is based on the operating system, the architecture, what we call as the platform, right? So here you can see that if you have, let's say you have written a game, okay? You have written a game in C++, so we can call it game.cpp. So your source code is the same, but you need to compile it 2 times. One's for your Windows, where maybe your game will compile into some binary like this, right? But in Mac it will be a little different. The same code will not be there. The machine code will be different. Okay, CPP is the C++ file. What is CPP? C++ source code. Just like .py is for Python, CPP is for C++ programs. Okay, so what is happening here? You can see that you have a different compiler for Windows, a different compiler for Mac. Can you guys see that? Okay, so basically the final binary is going to be different. So suppose you want to send this, you want to send the program to your friend. Okay, if you want to send the program to your friend, what will you say? You'll have to call him up and ask him, do you have a Windows machine or do you have a Macintosh? Do you have a Mac machine? Okay, you need to ask him. So if he says Windows, then you will send him the Windows machine code so that he can run the game and play it. Obviously, he will not sit and compile it. You don't expect him to have a compiler, right? Your friend just wants to play the game. So you can see that the machine code is different. The source code is the same, but machine code is different. Right? Even though the source code is the same. Source code means the program you wrote. That's the computer term for it. So what is this teaching us? This is teaching us that there is a platform dependence. By platform, I don't mean the railway platform. I mean the platform means, do you have a Windows machine, a Mac machine, a Linux machine? What type of machine are you using? Okay. So what is the problem here? In terms of running, there's no problem. But depending on different types of machines, because in Windows you can have a 32-bit system, a 64-bit system, there are a lot of complications. It's not just Windows. Okay, so depending on the type of machine and the operating system, you need to compile your program differently. So it becomes a headache that you have to compile it for various versions. You guys are understanding? You cannot have one binary version. 32-bit, 64-bit, these are different versions of Windows, different systems. Don't worry about it. Just I'm telling you that even Windows has different, versions of running this stuff. Okay. So then if we want platform independence, we go for something like Python or Java. So what is the magic? How is it doing it? So in Python, the source code, again is your program that you have written, program.py. Okay. Now the Python compiler, please see here, it does not convert it completely into machine code. It converts it into an intermediate language, right? Into something in the middle, intermediate language called bytecode. So that bytecode, right? The source code, you can see the file name extension ends with .py. In bytecode, the extension is .pyc. Python code, Python bytecode. PYC stands for Python bytecode. Okay, right? So it has, again, the compilation is done, but this bytecode is a kind of a special code. Again, it will be ones and zeros. If it converted, good question, if it converted directly to machine code, again we will have the same problem, right? That it will not work on the different machines. So what Python does is it converts it into an intermediate thing called bytecode. And let's see what is the magic of this bytecode. So what happens is that the bytecode is now not directly run on the machine. The bytecode is run by the Python virtual machine. So the bytecode that was generated is used not directly by your computer. It is run on a separate software here called the Python virtual machine. Exactly, it is just like the Java virtual machine. Okay, so you can see that this Python virtual machine is different. So you have one Python virtual machine for Windows, you can have one for Mac, one for Linux, and so on, right? 32-bit one you can have, 64-bit, whichever one your system is. So you must have that installed. So when you install the Python, language and stuff, it installs the Python virtual machine. You guys are understanding? Python virtual machine is just a software on your computer. What is this goal of this software? To be able to run bytecode. PVM stands for, right? PVM stands for Python Virtual Machine. Virtual machine. So you can think that this is a special software to run the bytecode. Okay, you guys are getting that? Right? So exactly, each machine has its own, like each type of machine like Windows, Mac, they have their own PVM, right? So PVMs have to be designed, Python virtual machines, for different types of system. But the best part is now your code needs to be compiled only once, right? Can you get it? So when you write your game.python here, now when you write your game.python, you just need to compile it once and you make it your game.pyc, Python bytecode. Now the best part about this PYC is it can be run on any machine, guys. The game.pyc can be run on any machine as long as you have the virtual machine installed. So you don't have to call your friend and say, do you have a Windows machine? Hey, did you buy a new Mac machine, or which one are you using? You just send your friend the Python bytecode, okay? And he is able to run it directly. Is that clear? Now the Python virtual machine runs it line by line. So this Python virtual machine is an interpreter. So that's why you read Python is an interpreted language, because the PVM basically runs it line by line. Runs bytecode line by line, one line at a time, line by line, and that is why we call it an interpreter. Difference between compiler and interpreter is interpreter does things one line at a time, compiler does the all the program, the entire program in one shot. It does the translation. Is that clear? Any doubts here? So can you see the whole magic is that you need to compile only once, and your friend whoever is running Python will have the correct PVM installed and they can use it. How do you send the game? Of course, if you do a file transfer, right? That's all. Exactly. So what does this tell us? Python is a platform independent language, and this is how the Python program is executed. So please understand, Python, like Java, is having two steps. First step is compilation. So it is not completely interpreted, that is half the truth. So first step is compilation and the second step is interpreted. Can you guys see? So both are happening. Compilation and interpreted. Interpreted is in the PVM step when it is run. Of course, C++ has this advantage that when programs are directly compiled, these are faster to run, right? Because it is heavily optimized in one shot. But in Python, when you run things line by line, definitely like Java, it makes the thing slower. Okay, so Python has that disadvantage that it is slower compared to a C++ game, right? That would be much faster, but then it has the huge platform independence language. And exactly that's why we said, right, Google made this famous statement, Python, where we can, C++ where we must. Because there are some places where speed is very, very important, right? In a game, or you can imagine in Google search and stuff, speed is important. So there, obviously, they are not just using Python. Okay. So what is Python bytecode? Python bytecode is a special code which is a set of instructions for the special virtual machine, the Python virtual machine. Okay. And it is a low level, right? So you can't really read this bytecode. It will look like zeros and ones. It will look like, garbage to you, because it is the computer's language, right? And why it is converted into ones and zeros, so at least it can run fast, right? So this is like a special bytecode which is at low level, right? And it makes the whole thing platform independent. Okay, and you can recognize these files as PYC files, Python code, Python bytecode. And then of course, like we discussed, you have the Python virtual machine. So what it does, it takes the bytecode and it converts it. So finally it has to convert it to machine code. So guys, you can see that once you have done this, this is where the PVM comes into play, right? The Python virtual machine. What is it doing? It is taking your byte code and converting it into machine code, which is finally run by the computer, right? So you guys can see that the source code is converted to byte code and the byte code is converted into machine code. All right, and this is run into the by the computer. So this part is a compilation step. This running is happening line by line. That is why we say this part happens line by line. So during the running it is converting. Please understand, the byte code is being converted while it is being run into machine code. It is not pre-converted. Okay, is that making sense to you? So this is being converted line by line while it is running. And so this is the part we say, that is why we say Python is an interpreted language. So we say it is being interpreted line by line. Line by line also has that huge advantage. It makes it easy for you to see the error, stop, you know. So let's say the error is in the 5th line. It will cause an error in the 5th line. So very good question. Sham is asking, how does the PVM know which operating system you are using? So when you download the Python, right, in the website it asks you that which system you are using. Windows, Mac, Linux, you should click the correct download button. These days, of course, the websites themselves are smart because you can actually ask, you can call a function, or they can actually detect the OS automatically. Sometimes they don't even ask you. That's a great question. So you must make sure the right PVM is installed. If the wrong PVM is installed, even if your sends you the best bytecode, the best game, it will not run. Okay, exactly. Now let's come to, so we have all understood how programs are run and compiled. All the details of Python are clear, right? At least at a basic level, your concepts are clear. Now let's see that when you are writing programs, there are different types of errors. Very, very important. And we are going to take a look at these errors. Okay. All right. So you have different types of errors. One is the basic error, which is called compile time error. What is the meaning of compile time error? These are the errors which are caught during the compilation of the program. So compile time error, as the name suggests, these errors are caught during compilation stage. Okay, so compilation means that first stage there, right? When you're compiling it, when you're going from source code to byte code. Is that clear? Okay, so the compiler errors, compilation errors, they are caught during compile time. Then of course you can have logical errors, right? So logical error means there is an error in the logic of the program, right? As the name suggests, the error during the in the logic, and we are going to discuss that. So maybe you get some answer, but it's not the correct answer. Let's say you have written a tax calculation program, but it's calculated the wrong tax, right? It's given you the wrong answer. Or you have written a program to calculate the volume of a cuboid, but it's given you the surface area. The program is run, but the logic is wrong. You guys got it? Yes, I'll talk about syntax, semantic, all the details. And then of course is the runtime error. These are caused during runtime. What is the meaning of runtime? So during execution. The word runtime means when the program is executing. Okay. Yes, we are going to look at these examples. So first let's look at syntax error. What is the meaning of syntax error? I told you it is caught by the compiler. So it is clearly a compile time error. And when does this happen? So this is like the simple errors when you didn't follow the rules of the language, right? When you are misusing when rules of language are not followed. It's just like grammatical errors, you know, like just the English teacher corrects your grammatical mistakes. For example, if you, forgot to start the sentence with a capital letter, or you have written a spelling mistake or something like that, you have not followed the rules of English language or whichever language you are writing in. Similarly here, okay? And these are easy to spot, easy for the compiler to catch, right? So suppose you're misspelling a word, or you can see in the example here, what is the syntax error? When you did print text, what is the problem, right? You forgot to put the brackets, right? So let's go into the Python code and take a look at these examples, right? So if you look at this program, When I try to run it, see what does it say? Syntax error. The first line is fine, but in the second line you can see we forgot to put the bracket. And see, Python is nicely suggesting here, missing parenthesis. Did you mean print x? So it is smart enough, right, to suggest to you that, hey, you forgot to do the print. Make sense? And suppose if I put the brackets, the syntax error will get fixed here. So if you put the brackets, now let's run the program. Okay, so it says enter a number. That input is, to enter the number, and we get 10. Parenthesis, the word parenthesis means brackets. That's another computer word for bracket. Okay, so very, very simple. And obviously if the brackets are not there, it will give error. There you can see that it's already showing a error here. Can you see it's like showing a spelling error, that red underline, can you see there? Okay, and of course when you're compiling it, so the program really hasn't run, it has found and it clearly says in the last line below syntax error. So these are very simple types of errors, right? Or suppose instead of writing print, so suppose you did something like print x and you wrote prnt. Now again if you do, right? So let's take a look here. See, what does it say? Name error. Okay, but when did this happen? It actually assumed that there's going to be a function here, but it got caught. So Python did not assume that, okay, maybe you had made a function called prnt. So name error means it didn't assume that, okay, you misspelt it here. So it didn't really catch it as a syntax error. It basically said that, hey, you don't have a function called prnt. So name error here actually happened during the execution. So you can see I at least entered the number. Did you see? I'll run it again for you to show you. So what is the difference here? Suppose when I make it print and now I click the run button. So let's actually, put another printout here. We can say program started. First, let's try it without any errors. This will work fine. So when I run the program and I say enter number, I say 20. See, you can see it's all working fine here. Okay. Now, if we introduce the syntax error, like we forget the brackets here, right? Can you see that the program never started? It's saying that there's a syntax error during the compile time. All of you can see that? Okay. Yeah, red line will show in, usually most of the IDs. Now, let's say I change this into prntx. Again, you can see it is giving invalid syntax. Can you guys see that? If I have not put the brackets. But now let's say I put the brackets. Let's see what Python will do now. Python is a strange guy, It keeps doing strange stuff. Can you see program has started? So you might have detected that, hey, prnt, it should be print. But what does Python say? It feels that you have written some new function. It's saying that maybe prnt is some new function that you have written or you have imported. So it says, okay, I'm going to run it and let's see what happens. Okay, because your syntax seems to be fine, prnt bracket x. But what happens is when I enter a number, now when it reaches the line, it says name error. It says prnt function or the print is not defined. Okay, it's like your class teacher says, suppose the class teacher says, Virat, are you present? Right? And there is no Virat in the classroom. So that's a name error, right? In the teacher's list, the teacher is expecting a student, right? The teacher has been given a list of the students in the class. First time the teacher comes in and says, okay, Virat, are you present? Right? So either yes, one is he could be absent, absolutely, or the students tell that everybody is present today, there is nobody called Virat. So teacher does a count, there are 20 students, 20 are all there, right? So that is like a name error. So same thing here, when the computer reaches prnt, it tries to run the function, but it is not found. So in Python, you have to be careful. This is actually considered as a runtime error because he could not find the name. Is that making sense? Because he is hunting for a function called print. So some of these are little hard. With practice you have to see, right, that the bracket, if is not there, then it's really a syntax. You have made a mistake in the language. Here it was expecting a PRNT function written by you or by somebody else. Okay, so let's get back to the normal syntax error like this, right? So this was our syntax error. Now let's go ahead and take a look at the next type of error. We have semantic error. What is the meaning of semantic? Okay, what is the meaning of semantic? If I say something like Virat plays cricket, okay, that's correct. But if I say something like cricket plays Virat, is that second sentence correct? Okay, so grammatically it's correct, right? Virat plays cricket, cricket plays Virat. So if we look by syntax, they are fine, but by semantics I'm not making any sense, right? So if we write this example, Virat plays cricket is fine, but if I say cricket plays Virat, so by English language it's fine. Maybe cricket is the name of a person and Virat is the name of a game, but we know that that's not true, right? So exactly, semantics means that there is no meaning here, right? So syntactically it is correct, right? But semantic is wrong here. So this we can say there is a semantic error. Same way, look at the example here, that when you say A equal to this, B equal to this, A plus B equal to C, you know that Python, this I've shown you earlier, you cannot do assignments like this. Do you guys remember this example? You can do C equal to A plus B, but you cannot do A plus B equal to C. You cannot do this kind of thing. So this is counted as a semantic error, even though you can see the computer prints it as a syntax error. So many times syntax and semantic are considered similar. So this depends on what book you're reading, you know. Yes, the L value, R value, very good, Sham, right? So it depends on what book you're reading, what classification. Sometimes semantic error are classified as syntax error, or, you know, or you can consider them differently. But basically it's a meaningless statement, even though it seems correct with plus and equal to. Okay, so let's take a look at this example here. When we look at semantic error, so if I try to run this program, see, it says syntax error, cannot assign the A plus B equal to C to the operator. So what is the fix here, guys? What should I do? Very good. So what we'll do is, we can fix it by saying, so this was our error line. And we are going to fix it like this. And there you can see it's working fine. C equal to A plus B. So you have to take care that it should make sense in the semantics. Clear? All right. So the fix here is A equal to B plus C. Similarly, the fix in the previous slide is, we should fix is to print of X. As I said, it does not show semantic error because the Python, this compiler, it considers the name as the same, syntax, semantic, right? But truly in terms of the theoretical classification, we count this as a semantic error. So it will just say syntax error. Clear? Now let's look at logical errors. So what is the meaning of logical error? That these normally you will get some output, it will work, it will look it worked, but finally the answer doesn't work as expected. So can you guys find what is the logical error in this program? Can you guys tell me? And I'll open up the program for you here. Okay, so here's the program, guys. And tell me what is the logical error in this program. So who can tell me? Let me run the program and show it to you. So let's run the program. I'm going to enter a number, let's say 20. And the next number is going to be 30. What is the average of 20 and 30? What is the average? 25. What does this program print? 35. I don't have to enter float. I can enter integer, it will treat it as 20.0, 30.0. That doesn't matter, right? So what is can you see the logic is the problem here? It worked fine, 20, 30, we got the answer as 35.0. So now guys, can you tell me? Very good, Maulik has got the correct answer. So what is the fix here? Krish has got the right answer, Ayush, very good. So please remember, right, the precedence of operators, BODMAS, this is maths, right? It will do or PEMDAS as we say in computers, parenthesis, exponent, multiplication, division, addition, subtraction. So it is first doing y by 2, then it is adding x. So please don't be fooled by seeing x plus y by 2 is going to work, right? So what is the fix here? This is the logical error. This is our logical error, right? Not following the BODMAS here. So what is our fix going to be? Otherwise the program is fine, it's running, but it's not doing the correct logic. So we need to put brackets around it. We have to do x plus y then divided by 2. Now do you guys agree? Or you can create a new variable, you can do x plus y and then take that variable and do by 2, but do it in one shot in one line. Now let's run it and see. So if I enter the number 20 and I enter another number 30, now can you see it's working perfectly fine, 25.0. You guys can see that? This is called logical error, where there is a problem in the logic, right? It all looks fine, it works fine, only that the answer is wrong, right? Okay, it's like you could solve the sum in maths, but you got the wrong answer. It's not that you couldn't solve it, it's working, it's running, but there is a logical problem, okay? And these are usually the hardest to locate. Can you guys guess why they are the hardest to locate? Because the program is running, program is working. Compiler is not helping here because all the syntax is correct, all the semantics are correct, everything is correct. There is no runtime error, it's all running, but there is a problem in your logic, right? So that is why the logic should be very, very correct, right? So there's no computer helping us. So we have to analyze the output and we have to fix it, right? Exactly. So you have to, that is why they give, these interesting examples that they will give you some error and say, find the error in the program. So you have to be the detective, right? So these are the hardest to locate because you need to be the detective here. And find the problem. Okay, exactly. And last is runtime error. What is the meaning of the word runtime? When the program runs. So runtime means when the program is being executed, when it is running. Execution of the program is called in computers runtime. Okay, so runtime errors, they actually happen during the runtime. It can cause the program, for example, when the program crashes. Have you seen that? Sometimes you open some software, you're working on it, and suddenly it closes. So that is a runtime error. Or you're playing some game, you're working on the game, you're playing it, enjoying it, suddenly the program closes. That is called, we say the program crashed, or sometimes the whole operating system crashed, right? We get a blue screen or something, right? The machine gets restarted due to that. So these are called runtime errors. Yeah, and it can be very annoying, right? And we also say some exceptions can happen. We'll talk about that. That can cause the runtime error. So let's take a look at some example here. So if you look at this example, what is happening here? Subtotal, it's asking you to input and then it's calculating the tax on it. Let's say the tax is, right, or we can make it simpler, 10% of it. So 0.1 multiplied by the subtotal. So let's go ahead and run this program. So when we run it here, okay, so you can see that if I normally run this program, what will it do? Okay, so what do you see here? What is the error? Can you guys tell me the error here? So you can see it's giving a name error, subtotal not defined. So can you find the mistake here? Very good. I think Cyan has the right answer, right? So it looks almost correct. Very good. Very good. I can see Ilakia has the right answer. Sham, excellent. Prithviraj, right? Capital D, small t, that matters. Okay. So don't think Python is case insensitive. It is a case sensitive language, right? Some languages are case insensitive, but this language is case sensitive. So it's looking for subtotal, and then it says it is not defined. So there is a name error. So actually it allowed me to run the program because it's running line by line. So the first line worked. Then when it went to the next line, it says, oops, I didn't find subtotal. Okay. So very good. So that is what we need to fix here. So this is what it is causing a name error here. So name error during runtime. And how do we fix this guy? Very simple. You guys have already told me the answer. So we just need to fix this, and you can see now when I run it, if I say subtotal is, let's say 200, okay, can't multiply sequence by non-integer on type float. Wow. So let's see what is the problem here. So you can see that there is another. So what is the problem here? So see, again there is a type error. Again we have hit a runtime error. Can you see? So very good. Like Krish is saying, we can give a int or a float. So we have to do type conversion because input actually returns a string. If you hover on this, can you see that? Can you see that last line here? It says it returns a string. All of you can see, right? So input will return a string. So I need to type convert it into a float. Now I think it should work. So let's try it again. Now is it working, guys? Int or float, but float is more general so that I can enter some decimal values also. So see that type error also happened, some type conversion problem that happened during runtime because computer doesn't know what you have input, what you have done. Okay. So that is a runtime error. Very good. Sham is asking a question. What about division by 0? Great question. So let's go ahead and try that. Let's try it in a new file here. So for example, so we can tell the user to input two numbers, right? We can say X, input a number, and then we can say Y. Okay, so this looks fine, this program. So let's go ahead and give this a shot here. So when I run it, it says input a number. Let me put some number, let's say like 10, enter another number, let's say 2, and when I divide, it works fine. Okay, and it can work for decimal values also, like you enter a number 3.14, and if I give 2.7 or 2.5, whatever, it does some nice division there. Okay, but what if now by chance the user enters 0? That's the fun of it, right? So let's say we enter 10 or 5 and the other number is 0. Now can you see? So it ran till there. Now it says 0 division error, or basically divide by 0 error. When did this happen? During the running of the program, during runtime. Do you guys see that? It's happening during runtime. Case insensitive language is QBasic. Okay, clear, right? So all I use this and I ran this program. So this is another famous example. So do you guys agree that this is a runtime error because it did right? Okay, one great question. Kirit is asking, is it a logical error also? Yeah, so partly it is a logic that you are doing a division, but why it's not a perfectly a logical error? Because like for example, some tax program, it says input your let's say it says input your entire expenditure, and then it says input the number of employees, right? So let's say input all the salaries of the employees, total amount of salaries paid divided by number of employees. Now if by mistake the accountant says the total salaries paid in the year was 1 lakh and employees are 0, it's not the programmer's mistake, right? It's the accountant's mistake or the person using the program. Do you guys agree? Because he wrote it correctly that give me the total salary spent, and so it's the user's mistake, right? So that is why normally division by 0 is treated as runtime error rather than logical error, okay? But yes, we can say it is a programmer error that we did not check for the, we did not do the check. So how will you fix this error? Because user may make a mistake, you cannot catch the user. Programmer cannot say don't make a mistake. He can make a mistake. Any user can make a mistake. So what should we do here to fix it? Very good. We can use a conditional statement, as Satya is saying, right? We can go for if else, right? Or we must check that Z should not be equal to 0. So we'll be talking about conditional statements and all in future classes. So this can be fixed so that the program doesn't end up doing something like this. Is that making sense? Right? So for example, what we can do here, we can say if Z is not equal to 0, oh sorry, if Y, so the divisor, if Y is not equal to 0, then you do this, else, right? Else what do? You simply print okay, right? So we can do this, if this thing, else. So let's go ahead and try this. Enter a number. So this one is working, and if I now enter something like 0, right? Okay, 1 second. There is a mistake in my syntax here. If this thing colon, 1 second guys. So it is having a, oh, 1 second. I forgot to put this in this line here. Did you guys see? So what is the mistake is, you have to put the Z equal to X by Y under the if, right? Yeah, so it should be under the if. No, we don't use curly braces. So if else, I just showed you the flavor here. We'll do if else statement next time, you know. So just to give you an idea, this is how you fix this error. Do you guys agree? Syntax for for loop and all, don't worry. We are going to come to all that, okay? So let's first understand the basics here. We will come to all the fun stuff. So all of you agree with this? That basically you will do only the division only if Y is not equal to 0. So this is smart coding. Clear? Otherwise, of course, it will give you an error if you do it without it, right? So we can have this type of error, or we can say that this is the division by 0, right? Can also cause runtime error. So another example is, then you had type errors. There are so many types of errors that can happen during runtime. Now you have something called exception. So division by 0 can also be treated as an exception. What is exception? An unexpected situation that happens during the running of the program. Because programmer may say, I asked you for the number of employees, but you gave 0. You gave me a salary 1 lakh, but you said employees is 0. How is that possible? Right? Okay. Or if I say, what is the number of students in the class? 0. Then the class should not be there, right? Okay. So that is also division by 0 is like an exception, right? Okay. Or we don't, or you can have something like file not found. Okay. So like one interesting thing is that basically that a program is trying to open some picture, and let's say the file is not found. Now that's not the fault of the program. Maybe the file got deleted accidentally, right? Or maybe the a program is trying to write something into your hard disk, but your hard disk got full. Okay. So is that the programmer's fault that your hard disk got full? Or the path is wrong, the file name you gave is wrong. So these are all kind of exceptions, right? They are not really programming errors, they are exceptions, unexpected situations that will happen. It's like when you are going on a road trip, suddenly there's a tire puncture. Was that expected? You got late because there's a tire puncture, right? So that's an exception. So unexpected situation. And the worst part is it happens during the execution, right? So you never know it before. It happens while executing. So as a programmer, what we do is exceptions are handled using exception handling, right? This is an advanced topic both in Java and Python. Basically, you have to catch the exceptions and handle them gracefully. So one of the exception thing we did here is what we did over here, right? We checked that, okay, is the divisor, if the divisor is 0, then don't divide. This is like catching an exception, unexpected situation. So we solved it here, right? But of course, the other exceptions can get complicated. Like how do you handle file not found, disk is full or memory gets full? Those are more complicated to handle, right? But ideally, good programmers, they will handle them gracefully. So this is an advanced topic that when it is handled gracefully, then the program will not suddenly crash. It will end properly, like our divide by 0 program. It will tell you, it will not suddenly crash or stop working. Okay, so these are called exceptions. And now one interesting thing we are going to talk about is debugging. So very interesting part, let's discuss this. This is the last part of the class, that what is the process of debugging. So this is what programmers have to do. What is the meaning of debugging? Bugs, finding the bugs. What are bugs? The bugs are basically your errors, right? So errors, right, in the program, they are called bugs. So when we are locating the error, correcting them, we call this process debugging. And I'll show you practically how to do debugging in Python, right? So what is the most common technique for doing debugging? It's simply called code tracing. What are you doing in code tracing? Suppose there is a problem, you start printing out stuff, okay? So what can you do? You can add some print statements. You can see, what happened, why did it happen? Or you can, go into debugging mode, which I'll show you. You can put something called breakpoints. So do you guys want to practically see how you do debugging? Do you guys want to try it out? All right, let's go ahead and try out debugging. Okay. So let's say, we had some program like this. Like let's say this was we had this logical error where everything is working fine, but the division is not working. So like let's pretend we didn't understand what happened here, right? So when we ran the program, we did 20 and 30 by 2, but we are getting 35.0. Okay. So what we can do here, clearly there's some problem in our answer. So how do we do the debugging of this? One very simple way is adding print lines. So how do we do that? You can simply add before doing the division, you can print out the value of x. You can even say, x equal to x, right? You can print the value of y, right? And of course, we are printing the value of z. So this is basically checking by adding print statements. So let's run it and see, because answer is wrong, but maybe x value is wrong, y value, z value, who's wrong? Okay. So let's run this and see. So if I run it, you can see that x and y is correct as expected. It is the answer which is wrong. So now you are being like a detective. Can you guys see that? You guys are being like a detective now. So what do we do here? That we know that x is correct, y is correct, but that z value didn't work out properly. Z value is wrong. So we need to fix it. Yes. So how do we fix it? Now we can focus on this formula, right? X plus y by 2. We know that there's some problem in that line. Let's say you're still not convinced. You feel it is fine. So maybe we can go ahead and even, print y by 2. Or you can even try this answer. Maybe you think some problem is in the z. Let's print directly this, we'll give it here. Again, we run it and see 20, 30. Again, we are seeing both times 35.0. So there is some problem in the formula, right? There is some problem in the formula. So now we have narrowed it down, and then we remember, oh yes, I have learned BODMAS in maths, right? I need to use BODMAS here. Do you guys agree? So there you can sit and find the problem, or PEMDAS, right? So parenthesis. So this is one simple technique. Let me show you another interesting way of how you can do debugging in Python, right? With this ID, all the IDs have it. So you can, when you go, rather than directly running the program, you can basically go into, when you click on this run menu, you can see there is a start debugging option here, right? Yes, when you click F5, okay. So if you just click this, let's see what will happen. So it will say give an option, debug the currently which configuration you want. I'll choose Python file, okay. And then when we say we run and debug, now you can see that I'm going to enter the number, let's say 20, okay. Then I'm going to enter the number 30, okay, and then it ran here. So it looked pretty similar, but what we are going to try and do something smart here is we are going to add some breakpoints, okay. Let me show you what that means. So when you click, you hover near the line, can you see that red dot here? So I can put these red dots. These are called breakpoints. These are basically a stop in the program, right? You're basically stopping on that line, and then you can continue line by line. You're putting a break over there so that we can analyze what is the problem here. So let's go ahead and try it. So we can again click start debugging with the Python file configuration, okay. And now you can see here, when the program will run, we are in this number, let's say 20. We can put some more breakpoints here. So we put some input like this, we put another input here, right? So you can see it is stopped at this position, right? Can you guys see? So it has, the program is actually halted here. Can you guys see the arrow? How did I insert the breakpoint? I'm just clicking with the mouse. See, if I click beside the line, the breakpoint gets turned on, breakpoint gets turned off. Now you guys can see in this variable list or this watch window, right? We can remove these variables also, 1 second. So you can see what are your local variables, what are the global variables. So you can analyze what are the variables of your program. So you have 20 and 30. So you can see the values over here. And now I can go step by step. If you go and click on this line, there's a option called step into or F11. When you press that, you will be going line by line. So let me click that. So see, it is going slowly line by line. It's not running the entire program. Now again, if I click the next line, it is going to calculate, it's going to print out this answer. See, again, I'm clicking the next line, it is going line by line. So I as a programmer, I'm having control. It's not running the whole program in one shot. It is going line by line. Okay. And you can see here, you can see what are the variables that are happening. So still Z has not been added. Now if I click the next, go one more step, you can see Z has got added here. Can you guys see on the left here? If you look at the left side of the screen, this local part, can you see Z? So yeah, it's like exactly very good, like Satya saying, I'm like the interpreter. I'm running it line by line, step by step, slowly. Okay, and I'm analyzing what are my values of my variables. You can also add the variables in the watch window. See, X, Y, Z. You can remove it also from the watch window. See, remove expression, or you can add it back, or you can say remove all expressions. And in the watch window, I can say, suppose I want to check X, or I want to check X plus Y. See, that's correct, 50. But we can see that by 2 is wrong. How did I open this? In the debug, this will automatically open. So you'll be able to see these options here. You can see, analyze the variables while the program is running. So it's like you're looking into the computer's memory. It's awesome, right? You're doing debugging step by step. Again, I click step into. So you can see now the program gets over. So we can analyze the program step by step, and you can put these red dots. They are basically breakpoints where you want the program to stop. First 2 lines, we don't want it to stop. It's simple input. Okay. If you want it to stop in the first line, you can put a breakpoint there also, so that you can do the entire thing line by line and judge it. I'll just show it one more time. Do you guys want me to show you? So see, if I click again on these, so all you have to do is click on the area to the left of the number, right? It's very nice. So if I click on and I put some red dots here, these are like breakpoints. You can put 1 or more. So now if I go and click run, start debugging, please choose that option. Then it will say what debug configuration. You don't have to worry about the rest. Go for Python file. I've clicked on Python file. So there you can see the program, it has actually stopped. It's not even asked me for the input till I click F11 or I press step into. So see, now it's going to say enter a number. Okay, I'll enter the number 20. Then it goes to the next line. Enter the number, right? I have to step into it. Now I'll say 30. Now it comes to the next line. Print. So see, I'm able to go line by line. I'm having control. I can analyze the values. I can look at the values even if we didn't have the printouts. So yeah, even if we didn't have the printouts, we can see the values here. If we remove the printouts, you can actually see what is going on inside. Let me show that to you. So see, step by step, and you can see what has happened here. So suppose let's remove these printout lines. Okay. So now you can see again, I'm going to run the program, run with debugging mode on, and when we start the program, step into, enter a number 20, enter another number 30. See, we are going line by line, and on the left, can you guys see the variables where my mouse pointer is moving here? Can you guys see the variables on the left, X and Y? Okay. So that is basically X and Y are the 20 and 30, these values. Okay, see 20, 30, we are able to see it, X plus Y, whatever you want. You can see X plus Y by 2. So you can actually check over here. You can actually put the formula here. Let's try X plus Y by 2 with the brackets. Then you say, now I got the correct answer in the watch window. You can actually use it by checking the value in the memory, in the watch window. Now you got 25. Now you continue. See, you can see now Z is 35. So you can see why there is a difference. And then we can finish the program by again pressing F5. Okay. So breakpoints allow you to have a break in the program, a stop, and you can analyze the value of the variables. Is this crystal clear? So this is the fun of doing debugging. You can put print statements, you can put breakpoints and go into debugging mode. Okay. So hope you guys enjoyed this class because we learned about a lot of new things today. Python bytecode and Python virtual machine magic makes Python a platform independent language. There are different types of errors, like compile time errors can be called syntax or semantic errors. You can have logical errors, runtime errors. We discussed about exceptions, right? Like division by 0 and all these kind of exceptions, type exception, name error, these can happen during the program. And of course, I showed you the technique, how to debug it line by line. It's really nice, right? You can debug it line by line, step by step, and analyze the program. And do check out the other courses on our website. I'm excited to let you know we are also launching the CBSE Class 8 Biology course. We have CBSE Class 9 and 10, Physics, Chemistry, Maths and Biology. So if you haven't taken the other subjects, do take them. We have, of course, Physics, Chemistry, Maths, ICSE Class 8, 9 and 10 courses. And then we have Java coding, Python coding, Physics and Chemistry for Cambridge IGCSE board. Alright guys, so now you can be good debuggers and you can analyze your errors and easily fix the errors, because when you're doing programming, errors are definitely going to happen, but you be the detective and fix them. It's like solving the puzzle, right? So hope you guys enjoyed this class and do share out our courses with your friends, and I'll see you next time. So please practice some Python coding and see you in the next class.